network addressing, internet address / port number. We already talked about what is referred to as port numbers, then also internet addresses. Now, look at the analogy given to you, or look at the illustration given to you there. From there, you can have like a good understanding what we're talking about. Now, look at the example given to you also, www.provarex.com. That's the URL, Uniform Resource Locator, www.provarex.com. Now, as a matter of fact, the www has a meaning, Provarex has a meaning, .com has a meaning. Now, some host names can actually have multiple internet addresses. We've not delved into IP addresses fully. So now, a computer that is connected to a network is not standing alone. You can perceive it as so that you say no one is an island. A computer connected with different other computers. They have IP addresses. They have MAC addresses. And what is MAC, or what do we know as MAC? What is known as MAC address? Looking at what we have on the screen, media access control. They all have like all computers all have like some kind of address that you cannot even change. IP addresses can be changed, but you see your MAC address cannot be changed. Take for example, when I talked about the NIC card, that's network interface card. So every network interface card or every network card on a computer, that's like a physical address. So now that hardware level address that uniquely identifies a network card on a computer, we can just call that like the MAC address. Moving on to the next slide. Please, any of these things that are not clear, if you're not clear with any of them, please, you can always read them up because it's very, very vital. So moving on to what we have there. Remember what we said about IP address. This time around, we are talking about a MAC address, which is a 48-bit number. Like I said, every NIC should have it. It uses the hexadecimal format. If you've seen something, look at this example that's written here. If you've seen something like this before, that's the MAC address. It doesn't change. It does not change. Yeah, it doesn't change. Moving on to the next slide. Moving on to the next slide. There are a limited number of IP addresses. That's talking about IPv4. There are a limited number of IP addresses. So that is why they now introduced IPv6. That's why they introduced IPv6. So, while other IP addresses are private and are meant to be used on internet network, some IP addresses are actually publicly routable. All these things I'm talking about, you can see them on the slide. That's on the slide I've provided. So let me quickly use this opportunity to explain to you IPv4 and IPv6. Although on a larger scale, we use IPv4. Now, IPv4, I think it's explained later in the material, in the slide, please just you can look it out later. IPv4, just like I said, IP means Internet Protocol. Okay, V is like version, so IPv4 means Internet Protocol version 4. Yeah. I already told you that it's like 32 bits. The 32-bit address. It uses if you want to identify it or recognize it, is A.B.C.D. The A represents any number from 0 to 255. Yeah. So doing the calculation, that's like around 4.3 billion unique addresses. Don't let me bother you with some unnecessary information. So because of that, now now a lot of devices are connected to the internet. So that we'll not have like all this clashing and the likes of that. That's why they now introduced IPv6, which is what 128 bits, very plenty. That's practically it's inexhaustible. You can't really exhaust it. Now, let's talk about NAT, Network Address Translation. From the picture you can see on the screen, it basically explains the whole process. There is something they call network protocol or protocol. Please, we'll be talking about it a whole lot. Something they call network protocol. At a point, we'll talk about FTP, file transfer protocol. At a point, we'll talk about HTTP, context transfer protocol, HTTPS. Anything that most of the time, any abbreviation that I see that's ending with P, just know that what they're talking about a protocol. Protocol is simply like a rule that must be followed for maybe data to be transferred or packets to be transferred. Please, we are getting to the main deal that we need to really pay attention to. Now, if you don't want to use the word rule, that's for all these protocols, you can use the word standard. That's like a pattern that must be followed. Now, let's look at what we have on the screen. They said there are different types of computers, Mac, PC, smartphones, and like that. How do they talk to each other when they are interconnected? The answer is the software that drives the network has to be standardized. Such software is called protocols. There are different types of network data out there, emails, websites, videos. How do the networking software handle so many types of data? That's saying the answer is there are several protocols. So in a very simple way, because all these ones that we are speaking here is like grammar. In a very simple way, protocols are like rules or standard or pattern or ways in which data is actually being moved. Moving to the next slide, we have network model. Please read this up yourself. Very important. Read it up yourself. I don't want to. This is like pure networking course. If I don't want to go into this to start explaining this. We have OSI model, we have TCP/IP model. Let me just give you the technique for those of you that will write the exam. If you want to master this OSI model, what's the technique again? I've forgotten. There's a way I used to master it back then when I was preparing for this exam. Something about pizza. Please don't throw. Okay, yes, I remembered. Please do not throw sausage pizza away. That's for the OSI model. Layer 1 is physical model. Physical. Is it physical? Sorry, physical layer, not physical model. Layer 1 is physical layer. Now, physical layer is, as they've said it now, physical layer. Talking about the physical devices. Layer 2 is data link layer. Layer 3 is you can see everything there. So the trick for it is, please, that's P for physical. Do not. D is for data link. N is for network. True. C is for transport. Sausage. S is for session. P, pizza, presentation. Away, A, application. So from OSI model, most of the time, when you want to master it for exams, you don't need to master TCP/IP model. Just know OSI model. The moment you know OSI model, you already know TCP/IP, because TCP/IP is where they merge some of all these OSI models together. Now, moving further, data encapsulation. That's like big word. Encapsulation means the process whereby ordinary data, a lot of things are added to it before it becomes what? A packet. No, to pass packet. So looking at what we have here, say at each layer in the protocol hierarchy, information is encapsulated with header and sometimes trailer data on the way down. At the far end, data is decapsulated on the way back. Just like if you know, for those of you that are interested in space travels, you know the way space shuttles move up. They go up as a full machine or object or body. Upon reaching up there, that's in space, they start toward jettison. That's different aspect of them will start to go away from them. What it means is that it's similar to this one. At the very beginning, what is leaving your system is what is data, just the ordinary data. Getting to the transport layer now, the header is added to it. That it forms the word TCP segment or the UDP packet. Moving further, IP header is added to it. That's when it gets to the network layer. The IP header is added to it. Moving further, a frame header is added to the IP header that has been added to the TCP header. Now, I know all these things, if you are very new to the field of cybersecurity, all these things will sound like, what is this guy saying? You'll be like, what am I saying, right? Let me calm down and see how I am going to break it. I've talked about IP, Internet Protocol. Okay, do we need the breakdown of this thing? Okay, please, if you want to get the breakdown, because we have like quite a long way to go. If you want to get the breakdown, you can still check it up. Probably watch YouTube videos on them. Watch YouTube videos on them. Okay, moving further, let's move to the next slide. Network protocols. And if you still want me to, in simple terms, explain data encapsulation and data decapsulation, I can still come again. Please, if you want me to do that, drop the explanation, just raise up your hand. If you want me to explain that process again. Okay, I can see a lot of hands up. Let me come through it again. Now see, I'll try as much as possible to break it down because I think it's even essential. Now see, let's use this example. Let's say you are sending, please, this is the example I will use. You need to understand it. This example. If you don't understand this example, I can do it again. Let's imagine you are sending a letter. You're sending a letter to somebody, like let me say a friend of yours. You now put that letter inside an envelope. You've done one thing. You put that letter inside an envelope. That envelope, you now see added address to the envelope. Maybe you wrote number 2, Jibola Street, Lagos. In that envelope that you added address, you now see put like extra information like stamp. Maybe you put like stamp again. This is the same way we are explaining this data encapsulation. Now, the extra information that you added represents like the headers and the footers that I mentioned. That header and footer that was mentioned that is added to the original data. Now, it gives you like a totally new package. Let's start again. The original data is what is the letter. What's the header? Like the address, like the stamp, like the sender's name. What is the footer? Let's see, like error checking, integrity checking. Remember when we were talking about CIA triad? When we were talking about C, then the I is for integrity. Integrity means you want to see if that letter is still the way it was when it sent it from the beginning. It has not been tampered with. Now, the encapsulation is like the opposite. Let's say that package now has already reached your friend. Your friend will do what? It's going to open the envelope. Definitely, it's not going to read the content of the letter without opening the envelope. It's going to open the envelope. Then it's going to read the letter. Then it's going to remove all the extra information that you put there. Now, that's the same thing. The person has gotten this thing. He's going to remove the headers. That's what we remember what we said. Address, sender's name, and what have you. He's going to remove the footer. He's still going to repeat the process of error checking. You get? And he's going to retrieve the original data. Is what is going to read the letter again. So I think that example has already explained data encapsulation and what decapsulation. So in case you have any exam, that definition is very solid. If you not still don't understand, you what? You go and read more. Okay. So all of data link layer, protocol layer, network layer, those are the things that we talked about. Now, internet IP, that IP address format. I will explain all this one to us. Now, please, TCP connection setup. Simple explanation for TCP connection setup. That's the ACK flag, the SYN flag, SYN-ACK communication from the client to the server. Now, look at the picture, look at the diagram that you have in front of you. That's going to give you like a perfect description of what you need to know. Now, I'll still explain this in a very simple way. So let's say you want to have like a conversation with somebody. Now, you are the client. Let's say the person is like the server. I'm sure you know what the server is. The server is basically anything that serves us. You get anything that serves us. You go to a party now, you want to eat rice. That man that is serving you rice, that man is the server. You are the client. This explanation is funny, but in reality, that's not the best way to understand all these things. Some of us we do all these computer classes in school, and yet we don't understand these very basic, simple, very basic stuffs. Yes, take for example now, an application is rendering a login page for you. What's doing that? It's the server that is doing that. What's it doing? It's serving the purpose of rendering a login page for you. You now go there and say, after I want to log in. You will now what? You will now log in. You get? So I'm sure like now everybody, we all know what servers are. You may be like, server, I don't know, I've not seen server before. You can actually have a server in your room. Yes, you can make it, you can create a server yourself. When you create a website and the database, everything is with you, you are the one, you can actually create a server yourself. So basically anything that is like, any application that is serving a particular purpose is a server. And you know what client is now? You now, anybody that's requesting for service. So now let's say you now, you're the client now, you want to have a conversation with like somebody, let's say the person is the server. Now, the first thing you're going to say, please, this is very, very important because by the time we are dealing with MMAP, we're dealing with Wireshark, you'll be seeing all these things in play. You'll see some kind of three-way handshake communication. Three-way handshake communication, very, very important. SYN-ACK, then ACK. ACK means acknowledge. SYN means synchronize. It should be synchronized, yes. So ACK means acknowledge. So SYN-ACK means synchronize and acknowledge. So now let's say you say hello to the person. So usually you're initiating conversation with the person, you want to talk to the person. Now, definitely now. Let me use me and a girl, not me and so I will understand it better. Now the person will now respond with like a girl now, the girl will not respond, hello, I'm listening, what do you have to say? That means they are acknowledging that they want to. Sorry, please. Christy, can you confirm if you can hear me well, please? Oh,
I can hear you clearly. Very clearly.
okay. So, Christiana is a deal. Let's assume I'm talking to Christiana. I'm the client. Christiana is server. Let's say I want to ask her for a number. So she's the one saving me that number, so she's the server. So I want to say, hello, maybe I meet her. Where can I meet Christina? Let's say in a club. I'm there in a club. And I say, Christina, I'm the one sending, yes, I'm the one sending that SYN flag to her. That SYN flag, SYN, SYN flag to her. Mind you, it's always a three-way handshake for the TCP connection setup. It's a three-way handshake. So I'm sending that thing, hello, like hello, I don't have a number or something like that. But let's have a hello. Then she's going to respond with, hi, I'm listening. What do you have to say? Why did you stop me? That's one means that's the SYN-ACK flag she's sending back to me. Yes, she's acknowledging my greeting and she's telling me that she's ready to listen to me. You understand? So I won't just stay now. I'm not a mugu. I actually wanted to collect a number. So what would I now do? And I say, hey, what's up now? Let's talk. Yeah, let's talk. That's an acknowledgement flag I've sent to her. That's an ACK flag. So I'm acknowledging their listening. So you see that what I've explained is TCP connection. The client sends a SYN packet, server responds with the SYN-ACK packet, and the client responds with an ACK packet. So that's what is called a three-way handshake. That's a three-way handshake. So proceeding, we have looking at what we have. Look at the screen. You can see. Don't look at early WWW model. We don't have time to look at those. Look at what we have. Our modern listing. I will explain. I will just right now explain the different verbs that we have for the WW model or modern web. That's the get, the posts, and others. Now in details. Please, those verbs, is it verbs? The word for it, I think it's, sorry, I might be using the wrong word. Verb is like, yes, I think it's verb. Please, when like for WW World Wide Web, when they want to communicate, let's say a browser, a web server, like what you can see on the screen, the browser, web server, and a file system. So there are like some very common HTTP verbs that are being used. Please take note of it because when we start using Bob suits, we'll be talking about them and see if we've talked about them before. So just like in the context of web development, see verbs, or you can call them requests. They are also known as HTTP methods, and they are used to interact with resources on the server. Example is, we have a lot of them. We have get, we have post, we have put, we have delete, we have head, we have options, we have patch. But the most important one that we are going to use, you see get, you see post. I think delete also, but get, post. You'll be seeing them very, very, very well, very, very well. You can see on the screen, you can see get. Then, so let me just talk about get. So get is just to, retrieve like a resource from the server. You use get. Post is when you want to send data to the server to create a new resource. You get, for example, let's say you're submitting a form or you want to create a new account. It's post request that you use. Okay, they are the requests. Yes, they are the SSP requests. I used the verb before. I think the best word to use is request. Okay. delete, we already know what delete is, to delete resource from the server, but I've already told you the most important one, the one that you must know it very, very well, is you see get, post, put, delete. You see get and post, know those two guys very, 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 very well. Tomorrow we'll be doing like more practical than what we've done today. So let me leave the floor for a lot of questions, please. We can always read up others. Leave the activity, leave the practical sessions alone. Read up others, leave the practical sessions alone. Tomorrow is going to be the time for the practical session.